let's take a look at a different way to make decisions using if statements that are nested. So imagine we have some sort of product. So what we're going to do is we're going to decide, should we um, phone a person to inform them of a product. So we'll have a product of some sort, and it's be based on a couple factors. So the first one is we'll get the age of the user or whoever that we're trying to determine if we should contact them or not. We are going to get a char. This one will be if they are a student or not. So this one will be yes or no. Then we're also going to have a char for, let's go with their credit rating. So we'll go with excellent. So this is going to be excellent or F for fair. So those will be our two credit ratings that our program will handle. So let's do some prompts first. So cout, what is the age of the customer? So we'll see in the age here. The next question we'll ask is, are they a student? So this one is going to be a yes, no question. So we'll see in student. And then here what we'll do is we'll ask them if their credit is excellent or fair with a different way of indicating what letter to put in. So cout is their credit excellent or fair. CN credit. Okay, so now we'll have all of our pieces of information. We'll be ready to make our decision. So what we do is in a decision tree, what we do is we start with the decision that is the root of the decision tree. And then we pass it on to different branches of the decision tree, and eventually we come to a decision. So our primary decision is going to be based on their age. So if their age is less than or equal to 30, we are going to make a certain set of decisions. Else, if their age is, let's say, larger than or equal to 31, and so we'll pick in a range here. Their age is less than or equal to 40. So this will cover all the ages from 31 to 40. We will do something in particular. Else if their age is, we'll go larger than 40, we'll do something in particular. And this would cover every single age imaginable. If you put in the age of 10,000, it'll be in this one. If you put in the age of -4, it'll kind of cover in this one. So this is our root decision is based on the age. And it causes 3 branches. So our program branches in, our decision tree branches into 3 different options. So what we're going to do is if they're less than 30, we're going to determine if they're a student or not. So that'll be the determining factor. So if student equals Y, then cout contact customer. Else, if student equals no, then we're going to cout do not contact. So we're not going to bother contacting them about this product if they're not a student. Now, if they are between the ages of 31 and 40, what we're going to do is we're just going to automatically contact them. So cout contact customer. Okay. And then if their age is larger than 40, the decision will be based on their credit rating. So what we'll do here is we'll do a cout, if their credit is excellent. What we'll do is we will cout do not contact. And then else if their credit is fair, then what we'll do is we will determine based on whether or not they are a student, whether or not to contact them. So we're going to branch this one further. So if student equals Y, then cout do not contact. Else if the student equals no, then cout contact customer. Okay, so what we've got is there's a series of branches here, and the best way to kind of visualize this is a little bit on its side. So I'm going to represent this so you don't have to copy down the what this looks like, because it's just going to look like a real mess here. But if I'm representing this as a tree, this is how it would look. So I'm going to move way over here. Our first category here that we're going on is based on the age of the person. So if they are under 30, I'll put the options for that here. If they are, let's say 31 to 40, I'll have a series of options down the middle. I feel like bumping this down a line. And then if they are over 40, I'll have the options under here. So this is how the tree would work. I guess if I'm drawing in branches, it might look kind of like this, although not really. So those would be like the three branches would be going in these directions. So now, if they are less than 30, what I care about is they are a student. Okay. Can I fix this? Yes, I can. Okay. So what I care about is if they are a student or not. Now, if they are 31 to 40, this is an automatic call. So I will say call if they are in this range. Now, if they are over 40, the decision is based on their credit. So now the next layer of this, if they are a student, I'm going to have two options here. So either no, they're not, or yes, they are. If they are over 40, either their credit is going to be excellent or their credit is going to be fair. Now, going down from here, if they are not a student and they're under 40, no call. Let's just abbreviate this as nope because it'll be a little bit easier to write. If it is a yes, then this will be a call scenario. Now, moving over here, if they're over 40, this one will be a nope if their credit is excellent. Now, if it's fair, though, we need yet one more decision based on whether they are a student. So I'll move all the way over here. So our two options are if they're a student, it's a yes, or it's a no. If they are a student, nope. If they are not a student, call. So what this does is it visualizes a little bit what it would look like, and I'll just further clarify it with some slashes. I don't know if this will confusify it instead. So we branch all of our choices in this manner. So from each variable, there are multiple choices that could occur. So the problem is this is how we usually represent a tree, like this, with branches coming from the top to bottom. But in C++, it's a little bit more difficult because you kind of have to imagine, maybe while you're watching the video, turn your head on its side and you can kind of visualize this as being the top and then these being the branches that are coming out of it as your visualization for this. So hopefully that shows you a little bit of a different way to represent choices in a tree. You can see even though it's nested, we did keep an and here because that made sense based on what our tree was trying to suggest. But yeah, it is a different way of sort of making decisions based on a variety of factors.